The development of the reproductive system is an intricate series of events where an embryo differentiates into male or female, forming the gonads, genital ducts, and external genitalia. Today, we'll explore how this process unfolds from conception to late pregnancy. Remember to check out King of the Curve at kotc.me for more study resources and in-depth learning. Let's begin. Reproductive development begins at conception when the sperm and oocyte fuse, creating a zygote with either XX or XY chromosomes, determining the genetic sex of the embryo. However, for the first 5 weeks, development is the same for both sexes. The embryo comprises 3 germ layers: ectoderm, mesoderm, and endoderm. The mesoderm, divided into paraxial, intermediate, and lateral plate mesoderm, plays a pivotal role. The intermediate mesoderm forms cylindrical structures called urogenital ridges, which house the precursors for the reproductive system. A strip of the nephrogenic cord, known as the genital ridge, develops into the gonads. This structure contains a mesoderm core covered by an epithelial layer. Early in development, cells from the yolk sac differentiate into primordial germ cells, migrating along the vitelline duct to the primitive digestive tract and up the dorsal mesentery, reaching the genital ridge by week 6. Upon arrival, these primordial germ cells signal the surrounding cells, leading to the formation of an undifferentiated gonad capable of becoming either testes or ovaries. At week 7, sex chromosomes begin expressing genes that direct gonadal differentiation. In males, the Y chromosome's SRY gene produces testis-determining factor, initiating the development of testes. The primitive sex cords transform into medullary cords that house primordial germ cells, forming structures like seminiferous tubules. Sertoli cells differentiate within the seminiferous tubules, secreting anti-Müllerian hormone to suppress female duct formation, while Leydig cells in the interstitial spaces produce testosterone, masculinizing the reproductive tract. In females, the absence of the SRY gene allows the gonads to develop into ovaries. The initial sex cords regress, and a second wave of cortical cords forms follicular nests around primordial germ cells, creating primordial ovarian follicles. These follicles house immature oocytes, paused in meiosis till puberty. At first, the embryo contains both mesonephric, Wolffian, and paramesonephric, Müllerian ducts. The path these ducts take depends on hormone presence or absence. In males, anti-Müllerian hormone from Sertoli cells causes the degeneration of Müllerian ducts, leaving behind vestigial structures. Testosterone promotes the growth of Wolffian ducts into the epididymis, vas deferens, and ejaculatory ducts, essential for sperm transport. In females, without anti-Müllerian hormone and testosterone, the Müllerian ducts persist and form the fallopian tubes, uterus, and upper third of the vagina. The mesonephric ducts, in contrast, regress without testosterone, leaving behind remnants like the Gartner's ducts. The external genitalia initially share the same structures: a genital tubercle, urethral folds, and labioscrotal swellings. By week 9, differentiation begins, driven by testosterone in males and its absence in females. DHT, a potent form of testosterone, guides the transformation of these structures. The genital tubercle elongates to form the penis, the urethral folds fuse to create the penile urethra, and the labioscrotal swellings merge to form the scrotum. In females, the genital tubercle forms the clitoris, the urethral folds develop into the labia minora, and the labioscrotal swellings become the labia majora. The external differentiation completes by week 12. The descent of the gonads is a final significant event. In males, the testes initially develop near the anterior abdominal wall and descend into the scrotum, guided by the shortening of the gubernaculum and movement through the inguinal canal. This descent is complete by the end of pregnancy. In females, the ovaries descend only to the pelvic region. The gubernaculum divides into the ovarian ligament, anchoring the ovary, and the round ligament connecting the uterus to the labia majora. To sum it up, reproductive system development starts from a shared foundation. By week 7, the presence or absence of the SRY gene directs the gonads to develop into testes or ovaries, setting the stage for the differentiation of the ducts and external genitalia. The descent of the gonads marks the final step before birth. Understanding the intricacies of reproductive system development is essential for mastering anatomy and embryology. To dive deeper and access more interactive study resources, visit kotc.me and explore all the tools available through King of the Curve. Thanks for watching. Stay curious, keep learning, and see you in the next video.